Welcome to the Crane and Hoist Rigging Training Module. This module will cover the following topics: the definition of rigging and slings, the importance of rigging to crane operations, types of sling materials, types of sling hitches, and safe rigging practices. The term rigging refers to any equipment used to attach a load to a crane's hook or load block. Slings are the most common type of rigging equipment. Slings are lines, loops, or bands that attach to or around the load being lifted. Another example of rigging is the hardware used to connect the load to the sling or the sling to the crane hook. Rigging is a very important part of safe crane operations. Unsafe rigging can cause unstable or falling loads, which can lead to equipment damage and worker injury. A properly rigged load is well within the equipment's load capacity, is stable and secure, and presents minimal danger to equipment or personnel. Safe rigging depends on these primary factors: the type of sling. The choice of sling is based on the attributes of the sling material. The type of hitch. The hitch is the way a sling attaches to a load. The sling angle. The sling angle refers to how spread apart the sling legs are. The lower the angle of the sling legs, the less the sling can hold. The load edge sharpness. The corners of a load can weaken or break a sling. The load capacity. The load capacity refers to how much the rigging is able to lift. And, finally, the stability of the load. The load should be secure in the rigging and not in danger of shifting or falling. These factors will be discussed more in depth in the following sections. Slings are the most common type of rigging equipment. Slings support the load, spread out the load weight, and make the load more stable and balanced. Slings can be made of many different materials and designed in many different ways. The four primary materials slings can be constructed of are wire rope, chain, metal mesh, and synthetic fiber. The following sections will describe these materials in more detail. Wire rope is the most commonly used sling material because of its combination of high strength and flexibility. Without wire rope, it would be impossible to perform most hoisting operations. Wire rope is typically composed of multiple metal strands twisted together. These strands are composed of smaller metal wires. At the center of the metal strands is usually a metal or fiber core. Chains are used for their great strength, for their ability to withstand high heat, and for their ability to adapt to the shape of a load. One disadvantage of chains is that they can be damaged by sudden shocks. Also, chains are only as strong as their weakest link. Both of these points are reasons why inspection of chains is very important. Metal mesh slings are made up of small, connected metal rings or other shapes. This results in a mesh sheet that is flexible and has a large surface area. Metal mesh slings are widely used in metalworking and other industries where loads are abrasive, hot, or sharp. The wide surface area of the mesh prevents single-point stresses that would occur on wire ropes or chains. Also, metal mesh grips the load firmly without stretching and helps maintain a balanced load. To prevent the sling or load from being damaged, sometimes metal mesh slings are coated with rubber or plastic. The most commonly used synthetic fiber slings are made of nylon, polypropylene, or polyester. Because of their softness, synthetic slings are the best choice for use on expensive loads, highly finished parts, fragile parts, and delicate equipment. Even more than metal mesh, synthetic fiber slings adhere to the contours of a load. They also have good shock absorbency, unlike chains and wire ropes. One disadvantage of synthetic slings is that they are not as temperature resistant as metal slings are. Another disadvantage is that they are not resistant to corrosive substances. There are 4 basic types of hitches: the vertical hitch, the bridle hitch, the choker hitch, and the basket hitch. The following sections will describe these hitches in more detail. The vertical hitch is the most straightforward hitch. It connects directly from the load block to the load. This type of hitch is best used with a shackle attached to an eye bolt or lifting eye. A vertical hitch should not be used for lifting loose materials or loads that are difficult to balance. The bridle hitch is composed of 2 or more sling legs that connect directly to the load. The bridle hitch provides load stability because the load weight is distributed evenly among the legs, and because the hook is directly over the load's center of gravity. One important note about bridle hitches: in configurations with 3 or 4 sling legs, 2 of the legs might end up supporting the majority of the load's weight. To protect against this, the load capacity of only 2 of the legs should be enough to support the entire load. The basket hitch is made by wrapping a sling around the bottom of a load and connecting the ends of the sling to the hook. In most cases, a single basket hitch will be too unstable, so a double basket hitch will be used. In a double basket, the legs should be spread far enough apart to balance the load, but not so far apart as to create low sling angles. A low sling angle creates the possibility for the sling arms to slide inward. A double wrap basket hitch is the same as a basket hitch. It just has one more additional wrap around the load. Because this hitch makes full surface contact around the load, it is good for lifting loose material. Additionally, the gripping effect helps prevent the sling lines at the bottom of the load from sliding inward. Rigging a choker hitch is done by passing the end of one sling around the load and through one eye or end fitting, then attaching it to the lifting hook. Similar to a basket hitch, the choker hitch can be done with 1 sling in a single choker hitch or with 2 slings in a double choker hitch. Also, the choker hitch can be done as a double wrap choker hitch, where there is an additional wrap around the load. This creates a gripping effect and is useful for carrying looser loads. Endless slings, also called grommet slings or round slings, are slings that form a continuous loop. Endless slings can be configured to form a wide variety of the hitches already mentioned. For example, a single endless sling can be put into a double choker hitch configuration or into a double basket hitch configuration. It is absolutely necessary to know a load's weight before lifting so that the proper rigging components can be chosen. If the weight of a load is unknown, it can be calculated. There are standard data tables that show the weight of common materials. This weight is then multiplied by the load volume to find the total approximate weight. There are charts that show the load capacities of different types of slings, different hitches, and different sling angles. These can come in the form of general purpose charts or product-specific charts from the manufacturer. Manufacturer charts should take precedence over general charts. The most important factor when using a sling is the sling angle. A sling can lift the most when the sling legs are closest to vertical and the sling angle is near 90 degrees. The smaller the sling angle gets, the smaller the sling's load capacity gets. The closer to horizontal the sling legs get, the more stress is put on the sling. This is easy to see with a real-world example. Which of the following two tasks would be easier? Holding two buckets with your arms down at your side, or holding the buckets with your arms straight out? It's easier when your arms are straight down because your arms have a greater lifting capacity when the load's center of gravity is beneath the lifting force. It is the same with the sling. A 1-ton load can produce several tons of stress on each sling arm at a low sling angle. This is why spreader and lifting beams are used for longer loads. They make the sling legs more vertical. The sharpness of a load edge is another important factor in rigging. The edges do not have to be very sharp in order to be a hazard. Any corner that a sling travels over creates increased tension at that point. Materials, called softeners, can be placed between the load and the sling to lessen the stress on the sling. Examples of softeners include specialized corner protectors and even just simple wooden blocks. A rigging component that bends a wire rope too sharply creates the same hazard as a sharp edge does. An example of this would be a small hook with a large diameter wire rope. If the rope bends too much, it creates stress. Devices called thimbles are used to make a gentler curve in the wire rope. The center of gravity is the point around which an object's weight is evenly distributed. To have a balanced load, the lifting hook must be directly above the center of gravity. The center of gravity may not be located directly in the center of the load. For off-centered loads to hang level, the heavier side will require a shorter sling leg. Rigging the load below the center of gravity can result in a very unstable load that could shift suddenly. The load's attachment points must be above the load's center of gravity. Tag lines can be used to stabilize the load during movement and to prevent the hoist rope or sling from getting twisted. Remember these tips when using tag lines. Never loop the line around hands, arms, or any body part. Wear heavy gloves to avoid rope burn. And avoid getting in potential crush points between the load and other objects. There are many types of hardware components used to aid the rigging and lifting process. Examples of hardware are shackles, eye bolts, and turnbuckles. The proper use of hardware components requires extensive rigging knowledge. Operators and riggers must be trained in the specific kind of hardware being used. All rigging components must be inspected before being used. If problems are noticed, the rigging should be rejected and should not be used. When in doubt about whether rigging is safe to use, talk to your supervisor. The following sections will describe how to inspect the more common rigging components. All wire rope should be inspected visually before use. Common problems with wire rope include broken strands. Broken strands can be spotted visually or detected by running a cloth over the surface to find snags. Wear. If the diameter of the rope has been reduced by more than 10%, the rope should be rejected. Heat damage. If the wire rope has come in contact with high temperature, check for heat damage in the form of discoloration or melting. Kinking. Kinks greatly reduce a rope's load capacity. Bird caging. This is when the rope strands have become separated, creating a bird cage effect. Bird caging greatly weakens a rope. Knots. Knots greatly weaken a rope. When in doubt about the safety of a wire rope, talk to a supervisor. Chains must be inspected for problems before use. Chain problems include broken links, bent links, stretched links, heat damage, corrosion, links with excessive wear, and cracked links. Also, chain slings should never be used if the chains are twisted or knotted. Hooks must be inspected for problems before use. Common problems with hooks include heat damage, wear exceeding 10% of the original dimension, cracks, nicks, or gouges. Throat opening is stretched open more than 5% of its normal dimension, and it should never exceed 1/4 inch more than its normal dimension. Hook is twisted more than 10 degrees from a straight-on view, or a malfunctioning hook latch. It is important to store rigging in its assigned storage location. Leaving the rigging in improper locations can lead to rusting, corrosion, and other damage. Here are some rigging storage rules. Never store rigging on the floor. Never store rigging in wet or damp environments. Limit exposure to very hot or very cold temperatures. Limit exposure to corrosive chemicals. And do not store synthetic fiber rigging in direct sunlight. Your facility will have specific personal protective equipment, or PPE, requirements and dress codes that you must abide by when performing your job. The right clothing and PPE can protect you from cuts, abrasions, and other injuries. The following are common dress code requirements when performing rigging work: hard hat, safety glasses, long-sleeved shirts, heavy leather gloves, and steel-toed shoes or boots. It's also recommended that shirts be tucked in so that loose fabric will not get caught on equipment. For the same reason, you should not wear loose jewelry at the work site. Electricity is one of the biggest dangers in crane and rigging operations. When performing an outdoor job, operators and riggers must know the location of all nearby power lines and live electrical components. There are specific OSHA regulations based on line voltage that determine how close equipment or workers can get to a power line. As a basic rule of thumb, just remember that crane and rigging components should not come within 10 feet of a power line. If a coworker appears to have been injured by an electric shock, do not enter the area or physically contact the person unless you are sure there is no danger of being shocked yourself. A qualified rigger is someone who has the abilities and experience to perform the rigging job at hand. There are many ways someone can be considered a qualified rigger, either through experience, education, or a combination of both. The employer will make the final determination of whether someone is considered qualified or not. OSHA regulations put in place in 2010 require that riggers doing construction work be classified as qualified when performing the following types of work: assembly and disassembly, hooking, unhooking, or guiding a load in the fall zone, or doing the initial connection of a load to a component or structure. In this module, you've learned some basic rigging principles, including the importance of knowing what type of sling to use, the importance of knowing what type of hitch to use, how the sling angle affects rigging, how the load edge sharpness affects rigging, the importance of knowing the rigging capacity and the load weight, the importance of load stability, the importance of inspecting all rigging components before use, the importance of proper storage, and the dangers of electricity. Every crane lift has unique considerations. Paying attention to the factors discussed in this training will increase your chances of having a smooth and safe lift.